Okay, chemistry. So here's your virtual Wednesday video. So I want to write on the double replacement problems page to find number 6. So on the double replacement page, I want you to find number 6. I think it's page 19. And it says this, Na2CO3 plus H2SO4. So take a second and find that. So the first thing we're going to do is we're going to analyze these two compounds, right, to see if they break apart at all. And so we do find that this one, the sodium carbonate, is soluble. We do find that sulfuric acid is soluble because I told you acids are soluble. They break apart. And so here's why this one is a little funky. There's a weird little thing on your page 15 and a halves, okay? And so I want to go through that right now. And so what ends up happening is you do this problem and you get this, right? So you put Na with SO4, okay? And this becomes Na2SO4. And then you end up putting hydrogen with carbonate, so that becomes H2CO3, okay? So hopefully everybody was able to do that part without any trouble. Now, so let's make sure I'm right so far. Yeah, Na2SO4, H2CO3. 2 NAs, 2 NAs, 1 SO4, 1 SO4, 2 H's, 2 H's, 1 CO3, 1 CO3. And so you would think you were done, but there's a little bit of writing on page 15 and a half, and I want you to find it. It's right here, dead square in the center of the page, okay? It's right above the chart, okay? And so it says this. When a double replacement, so it's literally this thing, right, my writing right here in the center. And it says this. When a double replacement, the following decomposes, right? And so one of those is listed. It says H2CO3, H2SO3, and NH4OH. Well, if you look up there, the second product that we have right here, right here, is H2CO3, which is right there. H2CO3. And so actually, in all reality, what would happen is this would do a double replacement, and then this would decompose. So the correct answer is actually this. Na2SO4 plus, and it says H2CO3 becomes CO2 and water. So this would break down into CO2 plus HOH, because I like writing water as HOH. And this is the correct answer. Fact. So it's just a little something that you got to kind of look out for, and it only applies if you have products. It doesn't matter if it's a reactant. It just matters if it's the product on this side, and we're making H2CO3, H2SO3, or NH4OH, okay? It shows up a couple of times on your pages, okay? Let's see, so when you look at the key, you're gonna see it show up at number 6, which we just did. I'm looking for other places. It shows up at number 26 as well, okay? So number 26 as well. All right, hopefully that's not too awful. All right. So we're going to turn the page now. So the next page is super duper easy. Like, it's really just a double replacement, but we give it another name, and we call them acid-base neutralization reactions. And kind of the name means what it says what it means, right? Just like Horton here's a who. With acids, we look for a hydrogen in something. With bases, we look like something in an OH. And what they do is they just switch partners. So what ends up happening is H and OH end up together, and these two things end up together. This ends up being the neutral part, okay? And water, we know from a pH standpoint, is also neutral. So we make a salt and water is what we say. All right, so if we look at number, let's see. Number 1, HBr. So this is hydrobromic acid. And hydrobromic acid, okay, is going to now react with NaOH. All right, so this is an acid because of the H in front of it, so hydrobromic acid. Sodium hydroxide, NaOH, is a base. So we got to ask ourselves, do these break apart? Yeah, you got to ask yourself, is it soluble? Well, HBr, we are going to say that all acids are soluble. So yes on the HBr. You go find NaOH. Well, you go find your chart on page 50 and a half. You go find sodium, which is towards the bottom. You move over to hydroxide. Sodium hydroxide is an S. It's soluble. So therefore, what's going to happen is we're going to have a switching of partners, where hydrogen and Na are going to switch. So what ends up happening here is Na and Br end up together, and what's left over is H and OH, water. And so what we end up making is we end up making what we call a salt and water. And this is what a neutralization action does. It takes an acid, it takes a base, it makes something called a salt, being a metal and a non-metal, and water. Now, I know we fall in love with salt because, like, you go to McDonald's, right, and NaCl's on your fries. But guys, by definition in chemistry, a salt is a substance that is a positive metal and a negative nonmetal put together. It's just an ionic compound, all right? So we make a salt and water. Now, balanced. 1H, 1H, 1Na, 1Na, 1OH, 1OH, 1Br, 1Br, and it balances. And guys, it's literally this simple for the whole page. So the hardest part about this is seeing an acid and a base, salt and water, just recognizing it's an acid-base neutralization. That's the first thing I want you to be able to do. But the second thing is just asking yourself about this soluble stuff. Remember, if it's an H, we're going to say those are soluble 100% of the time. So the only one you're really evaluating then, right, is the base every single time. So you go find your little hydroxide column on your page 50 and a half. So you come down here and you just look. And there's a lot of them that are I's and insoluble. So there'll be a lot of times actually where there'll be no reaction. Okay? I know that on your page, let's see, there are 2 of them. So, all right, so warning, there are 2 non-reactions on your acid-base neutralization page. So now you should be equipped with enough knowledge to do page 21 as well. So I want you to have the single replacement problems done, the double replacement problems done, and the acid-base neutralization problems done for tomorrow, okay? I'm also, because this page is so fast, I'm supposed to give you at least 30 minutes worth of work. You should know that I'm also going to assign you the next page, okay? So with the next page, it says A through E, and it says like synthesis, decomposition, single, double, combustion. I want you to add an F. You got that? So I want you on page 20, I think it's 22. I want you to add an F and write the word acid-base neutralization. I want you to make that a possibility. So I want you to have A synthesis, B decomp, C single, D double, E complete combustion, and F acid-base neutralization. If it's an F, acid-base neutralization, I want you to put that. I want you to put F. So you're going to do that page 2. So you're going to do the acid-base neutralization page, page 21, and you're going to do this page right here. There's nothing on this page, page 22, for you to have to balance, or anything. Literally, the reactions are already all there. So that's pretty nice for you on this page. The whole reaction is already there and it's already balanced. All you're doing is this part right here where you're telling me what letter of the reaction it is, okay? We will go over this tomorrow. So we're gonna go over single replacement answers. We'll go over the double replacement answers. You had a lot of work to do from last Thursday's class from that, right? We'll go over this acid-base neutralization answers for page 21, and then we'll go over the page 22 answers. We're going to play some music the next time I see you. All right, awesome. So I'm going to have you link some songs to types of reactions. So take care, have a good virtual Wednesday, and be well. Take care, y'all.